There we go. Hey everyone, welcome to the MacMillan Space Center here for another edition of Ask an Astronomer. So we have brought in our astronomer, Rachel, beaming in from across Vancouver, located on the unceded territory of the Musqueam, Squamish, and the Tsleil-Waututh. Hey Rachel, how's it going?
Pretty good. Yeah, I'm excited to talk about our topics today.
Yeah, we've got a lot of great topics to get to. Everyone that's out there watching on YouTube, how's it going? Let us know where you're watching from in the chat. And if you're watching on Telesoptic, hey to you as well. If you want to get in on our live Q&As, we are every second Thursday here on YouTube. So you can always find us on YouTube on our YouTube channel. Join us here. It is January 28th, Rachel. It is a full moon tonight. I'm not sure if we'll be able to see it here in Vancouver. Maybe where you are, you might be able to, but it's a special full moon. You want to tell us about it?
Sure, it's a full moon that's called a wolf moon. And I think that it comes from, or the lore comes from the fact that wolves used to howl at the moon during this time because food was really scarce.
Well,
Um,
it's the time of werewolves, right?
yeah, for full moon, yeah. Yeah, but I don't think we'll be able to see it, at least from my place here, because it's so cloudy in Vancouver.
Yeah. So it's not gonna be any brighter than usual. They call it the wolf moon because they have names for every full moon, but it is special because yeah, as we move along in time, it's a marker of the first full moon of the year. We're already 1 month into 2021, if you can believe it. And even locally, many different cultures have different names for full moons. And so the Wasanich people here in the Lower Mainland, the moon is called Ninine, which is the moon child, which is a rebirth. It's a lot of newness happening on the Earth, and as the Earth heats up, because our days are getting longer, right, Rachel?
Yeah, and I love the fact that it's a moon child and like uh, kind of keeping theme with 2021 being hopefully starting anew.
That's right. So we are getting longer days, and actually, we are getting to a point on Tuesday, which is Groundhog Day. And not many people may know this, but Groundhog Day actually is an astronomy. I don't know if you want to call it a holiday, but certainly a date that astronomers have in their calendars. So Rachel, is February 2nd Groundhog Day marked in your calendar?
It is not, but it is an interesting day that it's a cross-quarter day in astronomy, and it's really just another way for us to divvy up the Earth's orbit as it goes around the sun, just like we have equinoxes and solstices. And this particular one on February 2nd just happens to be the midpoint between the winter solstice and the spring equinox, and it just so happens to land on February 2nd.
So no matter if Puxatawny Phil sees his shadow or not, astronomers can definitively say we are halfway from winter to spring. It's going to get there eventually.
Exactly.
All right. Well, let's get to our big stories this week. We've got lots to get to. And of course, if you have any questions about any of the things that we've talked about, just put them into the chat. Of course, if you want to talk about other things that you've heard about or anything else, we'll get to that as well. But our first big story, Rachel, that we're going to talk about is Jupiter's moons. And I actually was doing a school workshop the other day, and somebody asked me how many moons Jupiter had. And I honestly had to think because I've memorized the number so many times and it's changed so many times. I think our current total, I have to actually look on my phone, is 79.
Mhm.
But I love how NASA says scientists think Jupiter has 79 moons. But one of those moons we are planning to go to with a mission. You want to tell us about it?
Sure, I'd love to. And it's funny that you said that you had to memorize the numbers of moons because Saturn semi recently got 20 new moons. So now Saturn has the most number of moons in our solar system. It has 82. So who knows how many more moons we're going to find in the next few years. You
Yeah,
might,
I'm sure Jupiter's not happy about that.
probably not, but I'm sure you have to memorize new numbers in the coming years. So we're talking about the Jupiter Callisto orbiter. And this is a orbiter that's going to be visiting one of Jupiter's Galilean moons. And this is going to happen in the next decade. So China is planning a few deep space exploration missions, and that includes visits to Mars, asteroids, and of course, Jupiter. Now, China's first Mars mission was called the Tianwen-1, and that consisted of an orbiter and a rover, and that'll enter Mars orbit on February 10th, right before the next Ask an Astronomer. And at the end of the decade, China is planning a mission to Jupiter to explore the planet as well as its moons. And they're working with the European Space Agency to launch a probe to the moon for approximately a 2035, 2036 arrival. And the spacecraft might carry a lander as well, and that would be intended to explore the surface of Callisto. And that lander would be very similar to the Chang'e lunar lander that returned samples from the moon. So that's very exciting that we could have a lander or a rover going across the surface of Callisto. But why Callisto? So Callisto is Jupiter's second largest moon. It's the third largest moon in our solar system and the outermost of the 4 Galilean moons. Now, this moon was once thought to be a dead end for space science, and it's been referred to as a hunk of rock ice because of its lack of active volcanoes, or
Rude.
the ugly duckling moon because it's the oldest and most heavily cratered surface in our solar system. But as it turns out, what looks like a barren moon might actually potentially have the right stuff to support life. So when the Galileo spacecraft flew by in the 90s, the data suggested that the interior could host a salty ocean, or it could have layers of ice mixed with rock and metal. And they also detected an ultra-thin carbon dioxide atmosphere, which we now think contains oxygen and hydrogen as well. So with a subsurface salty ocean mixed with rocks and oxygen in the atmosphere, Callisto does have the potential to support life. Now, over the years, a few different missions have visited this Galilean moon, starting off with Pioneer 10 and 11, which had close encounters with Jupiter in the early 70s, but didn't get any new information on Callisto that we didn't get from Earth-based observations. And at the end of the 70s, Voyager 1 and 2 imaged more than half of its surface and measured its temperature, mass, and shape. And that was followed by the Galileo spacecraft, which had 8 close encounters, and it flew as close as around 150 kilometers away from the moon's surface. And then in 2000, my favorite spacecraft, Cassini, captured the infrared spectra on its way to Saturn. And then in 2007, the New Horizons probe, which we'll talk a little bit more about later, captured images and spectra on its way to Pluto. Yeah.
So there's a few things that I want to pull out here. We've already started to get some questions around Callisto. First off, as we see the spacecraft called Galileo, and you initially called these moons the Galilean moons. So what's so significant about Galileo and Jupiter? They always seem to be tied together.
Sure. So Galileo Galilei, believe it or not, that is his name. He's the one who discovered these 4 moons around
Double
Jupiter.
G, as we like to say.
Exactly. Yeah, so we call them the Galilean moons, and they are Io, Europa, Ganymede, and Callisto. We do have missions going to the other moons as well, but I thought it was interesting to bring up Callisto because it was thought to be a dead moon and thought to be there's no activity, but it turns out there is tons of stuff to be found on Callisto.
Absolutely. And one of the really cool things, we already have been opening up our observatory. You can check out lots of the events that we've been having. Jupiter is not visible at the moment, but looking at Jupiter through a telescope, and I've seen it through our telescope that we have here, you can see the Galilean moons. And I find it just incredible to think about Galileo using his telescope, seeing those moons and completely revolutionizing our thinking around how our solar system all fit together.
You know, Michael, the Galilean moons and Jupiter was the first thing that I saw through our telescope on site.
That is amazing. Okay, let's talk about some of the other Galilean moons, because we've had some people talking about Europa. Why exactly? I get if you compare Callisto to the other Galilean moons, why are we so interested in these places?
So Callisto is a great Galilean moon to visit because it's actually costs the least amount of fuel, being the outermost of the Galilean moons to visit. With Io, Europa, and Ganymede, they all have kind of very similar characteristics. With Europa, we have also Enceladus, which is almost like the Saturn counterpart, Saturn's moon, that has a very similar composition to Europa in that it has an icy surface. There could be a subsurface liquid water ocean as well. But with Callisto, I mentioned that it was called the ugly duckling moon because it had such a heavily cratered surface. And so because there isn't any sort of weather, geological activity like we have here on Earth, where we have weather to erode the surface of the Earth, that they can change over time, Callisto doesn't have that. So any impact that it has on its surface is really a record, or a geological record over time, as to the formation of the solar system, because it's been around since all of these things are impacting Callisto and forming craters.
Oh, amazing. There's a few more questions we're going to get to, but
Mhm.
let's get to some more from YouTube. So, Christy asked, why was Callisto chosen? We've sort of talked about, lots of other moons that we are going to, but another question she asked is, how do they form? And I think that that's a really interesting question because, of course, Jupiter is pretty far away. So, how did they get out there in the first place if all of the rocky bodies, the planets, so to speak, are in the inner part of the solar system?
And it has to do with Jupiter's massive size. And so if we think about when the solar system formed, we talked about the fact that they form from planetesimals, and these are these Lego building blocks that clump together with gravity to form planets eventually. And with gas giants like Jupiter, it's more of the gas and dust that kind of comes together with gravity, is pulled together in the spherical shape to make this gas giant planet. But because there's so much stuff in Jupiter all in one place, it has an immense gravitational pull. So when we have things like planetesimals or smaller rocks that are around Jupiter, they'll get pulled into orbit. And so we call these captured moons when you have gravity capturing those moons instead of having them form somewhat more naturally.
Yeah, and you had talked about previously about the Trojan asteroids. So Pride, asks about how large the Jupiter field is, but it's hard to kind of like just give it an actual size because Jupiter's influence, maybe that's a better way to look at it, is a lot bigger than just looking at its moons. And you talked about in a previous video about those Trojan asteroids that we're going to be going to with a mission soon.
Yeah, so Lucy will be visiting these Trojan asteroids. And like you said, it's kind of difficult to define that region of influence. And we also imagine that there is a lot of stuff happening because of the asteroid belt between Mars and Jupiter as well. So there's a lot of rocks, a lot of chunks of things floating around in that space. It's a little bit messy.
Awesome, amazing. So that's our mission to Callisto. When I say our, I'm actually talking about the Chinese space agency, which was something kind of like slipped in there. But it's this reminder that there are different countries that are now really expanding their space programs, and I'm really excited to see that it's more than just NASA going out there. Now we're even seeing private companies. India's going back to the moon. This is really exciting development to see different countries because I think in thinking about was Callisto ever going to be on NASA's radar? They've got a lot of priorities, right? So, different countries can be like, okay, you're going to focus on Europa. Well, we're going to focus on Callisto, and maybe we'll beat you to finding that signs of life in the solar system. So let's go on to our second big story of the week, which is a really interesting one. You had mentioned New Horizons, which we know was the spacecraft that we had sent out to photograph Pluto. Those images came back, and then it went on to go by another, what we call trans-Neptunian object, and that was what was called Ultima Thule. And what is it called now?
Arrokoth, I believe.
Arrokoth, that's right.
Yeah.
Yeah. And so, yeah, New Horizons is just kept on going past those objects, but is also doing some amazing science. So why don't you tell us about it?
It is. So it's actually helping us answer a slightly different question. And so we know that space isn't completely black because we do see light from distant stars and galaxies. But the question is, how dark exactly is it? So the spacecraft, New Horizons, took measurements of the darkness of the universe to explain this sort of background glow that we have illuminating the universe. And that measurement, that data that it took, is known as the cosmic optical background. And that's the visible equivalent of the very well-known cosmic microwave background. You'll notice that they look very similar. But while the cosmic microwave background, or CMB, tells us about the first 450,000 years after the Big Bang, the cosmic optical background tells us something about the sum total of all the stars that have formed since then. And we can use this information to put a constraint on the total number of galaxies that could have formed. And that's another important question that New Horizons will be answering, is how many galaxies are there? Now, we do have an estimate for the number of total galaxies, and that was extrapolated from observations done by Hubble, such as the Hubble Ultra Deep Field, which I have here on the right. And that deep field image revealed 10,000 galaxies within an area that's roughly a tenth the diameter of a full moon. So if you are able to see the Wolf Moon today, you can imagine a tenth of that diameter being where Hubble was imaging. But these galaxies only represent about 10% of the universe's total galactic population, according to the estimates done from these deep field surveys. And so from that, researchers concluded that 90% of the galaxies in the universe were actually beyond Hubble's ability to detect invisible light, even after we gave the telescope equivalent of glasses. The team used mathematical models to estimate how many of these galaxies were too small and too faint for Hubble to see, and that gave a number of around 2 trillion galaxies in the cosmos. But Hubble is at a disadvantage because it suffers from light pollution as it orbits Earth, and also from something called zodiacal light. Now, I think that we talked about zodiacal light a little bit before, but I want to give a reminder as to what exactly it is and how it's affecting Hubble and its observations. Now, if we imagine the inner solar system being filled with these tiny dust particles from asteroids, comets, leftover stuff, and the sunlight reflecting off of those particles creates a sort of glow called zodiacal light. And you might have heard the other term, which is false dawn, to describe this phenomenon as well. And we can see this from the ground. So it's not just where Hubble is, where he is like 500 kilometers off of the ground. We can see it from here on Earth, and it looks like this little glow over here. Now let's go back to our first picture of New Horizons and take a look at the background. We see the sun in the center and also this glowing band across, and that's representative of the zodiacal light. And so to avoid this light, we need an observatory that is outside of the inner solar system, away from all that interplanetary dust and the resulting glow from reflecting sunlight. And so in comes New Horizons because it delivered the closest ever images of Pluto and Kuiper Belt objects, and it's very, very far away. It's billions of kilometers away, so it's far enough away from the inner solar system.
Wow.
And in the extended phase of its mission, New Horizons is exploring more Kuiper Belt objects, and so it is far away enough to make measurements on this cosmic optical background. And because it's so far away, the sky that this spacecraft sees is actually 10 times darker than the darkest sky that Hubble was able to see. But even from the special vantage point of New Horizons, far away from light pollution, these kinds of measurements are still extremely difficult to obtain. And so in order to see this extremely faint glow, the team at the Space Telescope Science Institute in Baltimore had to correct for a number of factors. And a very similar process was done for maps of the full sky as seen in infrared light, which I have here on the left. And infrared light is close to optical light in terms of wavelength. And so we'll use it as a close enough example as to their process. So if you take a look at the first picture, the bright yellow-orange line that you see going across the center is that interstellar dust in the plane of our Milky Way galaxy, with the center of the galaxy being in the center of the image. And then the middle picture is the view of the sky after the glow of solar system dust or zodiacal light has been removed, but that interstellar dust from the plane of the Milky Way is still present, and that's actually even more challenging to remove. And so in the third picture, we removed both of these. We removed both the dust from the inner planets and also from the Milky Way galaxy, and it leaves behind a very, very faint signal that is still measurable. And I thought it'd be cute to show you exactly how faint the signal is. And so researcher Mark Postman from the Institute compared it to living in a remote area far away from city lights and lying in your bedroom at night with the curtains open. And then if you imagine your neighbor a mile down the road opens their fridge for a midnight snack, the light from their refrigerator reflecting off your bedroom walls would be as bright as the background that New Horizons detected. So it's very, very faint. So the next question being, what is the source of this glow? And that gives us this sort of bright, dark sky. And we have a couple of theories, like maybe there is an abundance of dwarf galaxies, galaxies with billions of stars rather than the hundreds of billions like the Milky Way has, that lie just beyond the limits of the sensitivity of our instruments. Or it could be this diffuse halo of stars that surround galaxies that might be brighter than we've thought before. Or there could be rogue stars that are spread out throughout the cosmos. Or there very well, and perhaps most interestingly, be more faint, distant galaxies than our current models suggest. And so that last hypothesis would mean that the trend in sizes of galaxies is a lot more different than we thought. And perhaps many more small galaxies lie beyond the faintest systems that we can see. And this is really very similar to how beaches have more pebbles than rocks on the beach. And yeah, so that's actually one of the questions that New Horizons is answering that I'm most excited for, is this weird glow happening.
Well, so if we back this up a bit, we sort of can understand we live in a city that is very light polluted, and it's kind of like we're inside the solar system. We also have the light pollution of all of the other stars as well, which makes it challenging to
Mhm.
see those distant galaxies. So if we do sort of like go back, in time to kind of like Galileo days when he was just looking at Jupiter through the telescope, he hadn't quite realized that there were galaxies that were not part of our galaxy. And one of the really great questions that Jackson on YouTube just asked is, how did galaxies form in the first place? We're not all part. We're all kind of like in our separate little islands, and that's something, of course, with telescopes that we discovered. So, how did they form in the first place? And they were also different, also separate from each other.
Sure. So the process is very similar to when solar systems form, but we're doing this on a universal scale. So if we go all the way back to right after the Big Bang, we know that the Big Bang exploded outward in this violent explosion. And what was left over, we see in the cosmic microwave background. So that's that funky map that I showed you with blues and reds and yellows.
Mm-hmm.
And you might have noticed that in that map were different spots of red that had higher densities and higher temperatures, which means more stuff was there. And because there were differences in densities, these are the areas that material started to clump together, because these areas had just slightly more gravity. And so as things started to clump over the years, over a few billion years, these galaxies started to form, and along these places where we had these density fluctuations. And we see that as the cosmic web. And in between those spaces, in the blank spaces, is the cosmic voids, or our cosmic voids. And the reason why we have galaxies staying together when we have the accelerated expansion of the universe that we know is happening is because of actually dark matter actually holds galaxies together. Yeah.
Yeah, that's really wild and interesting to think about, because, even if you just go out and look up at the nighttime sky, the closest galaxy to us is really faint, Andromeda. But to even like try to wrap your head around, what's going on in those other galaxies, must be a big challenge for astronomers, isn't it?
I'm laughing because, initially, maybe in the first week when I went to astronomy class, that was the case. But I'm just so desensitized to all the weird things that are happening in space that you could tell me anything was happening in space, and I would say, okay, okay, that
And
makes
of
sense.
course, and of course, that's we make estimates, right? Because it's like I always use this analogy of we're like an ant in the middle of the apple trying to understand what the apple looks like, but we can't because we're inside of it, and we also can't see on the other side of it, but we can see, in these directions, like up and down, but not like across the plane of the apple.
I love that actually, because you can imagine if we were an ant on some sort of surface, we don't know if the surface, the larger shape or the universal shape, is different, because we could think that it's locally flat and looks flat to us. But if we zoom out, we could be on something like a donut, but we would never know, because to us, as little ants, it looks flat.
Yeah, exactly. Let's stick with New Horizons. We got a question from Marino. Is New Horizons expected to be farther from Earth than Voyagers at some point?
Is New Horizons? I don't believe so. No, because Voyager 1 and 2 have both left the solar system. So they've left what we call the heliosphere, and that's the influence of the sun. And that's kind of how we define the boundary of our solar system. But because New Horizons is exploring more Kuiper Belt objects, it's still within the bounds of the heliosphere.
Okay. Will it now? Is it not going to catch up to them, or is it's still going to? Voyagers will always sort of like be further away.
I imagine that they would always be further away, but most likely the Voyager 1 and 2 communication systems will probably fail before New Horizons does.
Amazing. And since we are talking about light, really quickly, we're going to have to do like rapid fire answers here, because we have a question about, black holes and why, let's see if I can get the question right here. How come black holes are invisible to, I guess, to like visible light?
Sure, because black holes only interact through gravity. So their forces are not unlike the forces that you would have with a planet that has gravity as well. And so when we have or are looking for black holes, they are this region where we can almost imagine it's a pinprick in the fabric of space-time. So it's really not a place where you have a ton of matter. It's really this place of infinite density, infinite gravitational pull, and that would be the singularity in the center. But if we wanted to look for black holes, because they interact through gravity, then we can look at things like gravitational lensing, so how they affect the path of light. So in that way, we can use light to look for black holes, but we're really looking at the effect that black holes have on things nearby.
Right. Good job to answer that big question in a short time frame. And I'm going to give you another really big question that you're going to have to answer in just a couple minutes, because it's actually 3 questions all in one, but they're all related. So first from Henry asks, what caused the Big Bang Theory? Related from Olivia, how do you know that the Big Bang is real? And then also related from Joaquim, how many universes are there? I think that those are all connected.
And they are. And
Yeah.
so I'll try to do a rapid fire answer here. So the Big Bang Theory is commonly thought to be from the start, from the initial explosion and onwards. But the Big Bang Theory really tells us how the universe evolved after that initial explosion, but it doesn't tell us how that initial explosion happened. And in terms of multiple universes, because we have a limit to the speed of light, the cosmic speed limit, we can only see so far. So the boundary of how far we can see is called the observable universe. We have no idea what's beyond. We can't ever test anything that's beyond. So if there's multiple universes, maybe that's the case, but we haven't seen any other influences of other universes existing happening in our universe. So to our best knowledge, we are the only ones here. And then there was a question on, what was it? There was another question.
The Big Bang and the reality of it.
Right. So whether or not, or how do we know that it's true? And our best evidence for the Big Bang is the cosmic microwave background. And that really gives us evidence for this density variation. So from that density variation, we can actually have cosmological models or simulations that show us that given this Big Bang model, that the universe evolves exactly the way that it should.
Yeah. And I think that there's sometimes we use words, and when Big Bang Theory is kind of like put together, and people think like, oh, that's just like any idea, any kind of like theory that anyone has. But really what you're talking about is like, this is like the foundational knowledge that we build all of science around. It could be proven wrong, but at the moment, this is what we have to work with. It's not just like some wild theory. It's like we all believe that this is true, just kind of in the same way that we all believe that gravity holds us down onto the Earth. That also could be wrong as well, probably not. But but when you use the word theory, we mean like this is what we believe in.
Yeah, and I'm going to hold the Big Bang Theory as the theory until we come up with a theory of everything, and that'll become my next the theory.
Absolutely. Okay. Another rapid fire question. Dark matter, dark energy. Could you, in a minute, describe what those are?
Sure. So my joke is that cosmologists only know 5% of the universe because 5% of the universe is ordinary matter like you and me. The rest of the universe is stuff that we don't know a lot about. So that's dark energy, which is around like 68%, and then dark matter, which is something like 23%. And so that composes the other 95% of the mass energy content of the universe, which we know more about what it is not than what it is. So it's kind of like if you were taking a multiple choice exam and you could cross off answers, we're slowly doing that and trying to dwindle down to the right answer.
Exactly. Hopefully you got that. That was a really great explanation. It's kind of like the D, the not A or B. That's what dark energy and dark matter is. It's kind of like that other parts of the universe that we don't quite know yet. We have a couple names for it. Still trying to figure out. Great questions. Let's see if we can squeeze one more in here. Our last one. Who thought of the Big Bang Theory? That could be a quick one. Was there somebody that initially thought of it?
Oh, I don't know, actually.
We're gonna look that up. Maybe we'll bring that up in our next Ask an Astronomer. Let's end there. You can keep putting your questions in, and we'll put some answers into the chat afterwards. But I want to let you know that we are going into February, which is our Mars month. So if you go onto our website, you're going to see a whole bunch of events that we're going to be doing all around Mars. On February 18th, the Perseverance lander is going to be landing on Mars. So we're going to be doing a special Cosmic Night online. Rachel and I are going to be joined by Dr. Tanya Harrison, who helped pick where Perseverance is landed on Mars. It's going to talk all about the geology on Mars. So it's going to be a really fun evening on February 18th. Of course, February is also Valentine's Day month. So on February 14th, we're going to do a special event where you are going to get a chance to send a stellar shout out to someone that perhaps you're missing right now. Perhaps you have a relative that you haven't seen, or maybe a friend. Come on to our event. You can send us an email. There's a deadline. If you click onto the link on our website, send us an email of who you'd like to send a stellar shout out to, maybe a special message. I will read it out during the event on February 14th. Rachel is going to pick a star that we are going to fly to and dedicate to that person. So check that out. It's going to be a really fun little evening. We're going to do some trivia, give away some prizes. February 14th, our Valentine's night event. And just because we have so much stuff going on, we're going to do another event on February the 8th, all around space debris. And this is a growing topic as we send more things up into our low Earth orbit. Things that maybe are not even working anymore, even like loose screws from old satellites. All of that is accumulating space debris. So we've got some special experts that are thinking about this topic, and we're going to have a full hour dedicated to these experts, all talking about the latest ideas around mitigation and just understanding what space debris is and what how we can help solve it in the future, if we can solve it.
I'm actually going to make a quick correction to that date. So Space Debris Day is actually on the Wednesday, and that's February 10th.
February 10th. Thank you, Rachel. I'm just going off. I got so many different dates in my head. It's like the moons of Jupiter.
So many numbers.
So many numbers in my head. So thank you so much for everyone. We're going to go and answer all of your questions in the chat. Not to worry, but we will be back here on YouTube in 2 weeks on Thursday. We will see everyone again then. Have a great wolf moon, everyone.